The Sporlan division of Parker Hannifin proudly sponsors the Advanced Refrigeration Podcast. There are a lot of questions surrounding the transition to A2L refrigerants and a lot of talking heads disseminating nebulous answers. But when your technician is face-to-face with the first A2L transition project, where do you turn for real-world answers about this specific job? Parker Sporlan's Virtual Engineer is an innovative online design tool to size and select the correct components for climate control and refrigeration applications. Get your A2L system flow and component selection answers in 3 simple steps. Enter your application details, size, and select products, then download your project files. It's that easy. Try it at absolutely no cost. Visit sporlan.com and navigate to the Resource Center. Parker Sporlan, leading the charge.
I mean, it unfortunately, like, naturally comes out. So that's why, but I'm tired. So, like, it just, sorry.
Oh, you're tired. You slept all day.
Man, I had a panic attack. I just straight up sat in a car for 3 hours because I was at that conference and I realized that I had to make that presentation a little bit easier.
Yeah. I had a panic attack from eating gas station barbecue in Atlanta.
And what happened?
It was not good.
Panic attack, like you had to go to the bathroom and couldn't get to the bathroom?
No, yeah, just not good. Tummy aches from hell. Very disappointed.
So, good afternoon, everybody. Welcome to Advanced Refrigeration Podcast. You're the host, Brett Wetzel and Kevin Compass. So, how was Atlanta? I didn't get to really talk to you because we were all busy.
Not great. It was cold then hot, then cold then hot, and I have an awful sunburn on my neck because we've been living in sweatshirt and coat weather for months up here. The sun down there is much hotter, so it just torched me.
What were you working on?
I was doing Microthermal RTU upgrades. So on stores where they did a rough sweep, and then I had to integrate a bunch of older Aeon units and bring them up to spec, and then got to deal with the plethora of issues with the old units, including me making a board go bye-bye.
Yeah, I got the text. What happened? What happened with that?
Somebody flipped the polarity on the outside air damper actuator, and when I wired it up the same as all the other units I did.
Oh.
So I didn't check anything because this is the 4th unit I've done, and it's okay. I'm landing everything on terminal blocks. Nothing was hooked to these terminal blocks before, so when I turned the disconnect on, it just went. Oh, I had my headphones and I didn't really hear it, and then I started smelling something. I'm like, something smells burning, and I took my headphone out. I could just hear, and I just watched the smoke pour out of the board. I'm like,
So the signal that you were sending out, you sent to the negative of the terminal, and then it fragged it.
They had 24 volts on what should have been the negative.
Oh.
So when I hooked the negative to the microthermal board, it was 24 volts. So it put 24 volts on the ground terminal for the AO, and then it went night.
Not good.
Yeah, it was a little bit of a disappointment.
I had something like that happen years ago when I first came here. They were trying to figure out what was wrong with the Seasons 4 unit, and they used those controllers that they use to cycle the fans off the liquid temperature. And the schematic shows for everything to be wired up a certain way, and someone decided to unwire everything. So I followed the directions that were in the box. Actually, after one person fried 2 trains, and then I went there and I was like, wow, you're doing it wrong. And I went there and fragged that one. I was like, what'd I do? I followed the schematic to the letter. And so I called, I forget who makes that damn controller, but I called the cat and I was like, so what's up with this? And he's, oh, you wired it backwards. I'm like, not apparently what the directions say. Hoffman controller, that Hoffman controller thing.
That sequence controller.
Yes. Yeah. It's essentially like a loop sequencer. And I sent it to him and I was like, this is what I have. He's, oh, I'm like, what's, oh, he's, oh yeah, we don't have the schematic for that particular unit that you have is different. It's just different than any other one. I was like, So you caused me to fry that one up. So they sent me a new train out, and then they put an update on their schematics on this is how the way it is, unless you have this one, and then put the right one out, because otherwise you wire it backwards and you're essentially sending the voltage to the 0 to the comm, and then it doesn't like it. And then it smokes, lets smoke out.
Yeah, it gets real burny real quick, and AOs are not very forgiving.
No, there's no safety in those. We were talking about some stuff when I was doing training when I was down in Memphis, and the guy brings out a case controller, and he's like, "Yeah, water got on this one." And I looked at it, I was like, "I don't see any water." And I had put on a presentation where it showed someone sticking a screwdriver in one of the solenoids for the pulse width stuff. And it had on those relays, it's either a transistor or a solid state relay. And I was like, you don't do that because it's not as forgiving as what a mechanical relay is. And he's like, yeah. And then later he's like, yep, that's exactly what I did.
Solid state relays take it a little more. The board solid state relays do not take it.
No, like a mechanical relay will take it, right? It'll take the little bit of amps that you maybe have when you take it off because there's no coil to basically do what it needs to do. But when you have like solid state or a transistor relay and you do that screwdriver trick and you don't do it fast enough, it goes a little burny on the board.
Yeah,
I guess we're going to finish up. We're actually going to do something that we always say that we're going to do and finish up something that we were going to talk about. So we'll finish
dive back into the 800A.
Yeah. And then I figured, so this coming week, I'm actually going to Pittsburgh, and then I'm driving out to Fort Wayne, Indiana. Huh?
Ew.
I know I got to go through Ohio.
Ew.
Yeah, I know. Yeah.
You're going to see a lot of Amish people.
I'm used to Amish people. Actually, when I moved up to Connecticut, everyone would call me Amish because I had a big old beard and I was from Pennsylvania. So that was the ongoing joke for, I don't know, 2 years. Thanks, TJ. But yeah, let's get into the finish up this 800A stuff. And bam. So if you remember from last week, we did the rack, we did the suction. We only did one suction group because we were just doing a regular chemical refrigerant rack. We told it reciprocating compressor, all these stuff right here. So we got through all that other stuff. And then let's see, refrigeration. What didn't we do? So we did a circuit. We did a condenser. Let's see, rail heat. So have you ever played around with the adaptive rail heat?
I have not played around the dip rail heat. We don't ever use it. So I think you have to have a sensor on there, and then it calculates off a dew point and does that. We just do the normal rail heat where it gives it a set point.
Oh, so you do I want to say an analog or loop sequencer, but it's not called that here.
No, it does it on its own. So it does. I guess we do use adaptive rail heat because there's no other option.
Yeah.
So dew point method, calculated dew point, and then we use the HVAC humidity.
Yeah, because you can either give it a dew point sensor, which automatically figures it out, or you have to have calculate, which would be the relative humidity and the space temperature, and that's typically what everyone does, right?
Yep, and we use the HVAC humidity, and then it automatically, if you have an HVAC controller, it automatically like binds it to
there. Yeah.
Yep, and then it's simple. It's cut in, cut out, basically. Like you give it a set point, and then 90% of the time it doesn't work and is bypassed.
Okay. I don't think that I went to comp view. I don't think this will actually work on here because there's no scan devices in order to do such. That would be, I'm assuming that would be a pack controller. So that's not going to do nothing. Rail heat. All right. I guess we're on our way to addresses then. So go to test rack ARP. So this is where you would break down your addresses on basically the nodes and that for the circuits. I'm trying to think.
So that's for controllers. So that's for the actual, if you're using case controllers. Now we're doing this as a chemical refrigerant. We're not going to have any fancy case controllers. So we're going to go to relays first at the top. Don't go to that. Go to relays at the top. So this is where you're going to put in your relays and your naming of relays. Now, some customers are very adamant about how they name things. This is where you would rename it and make sure you name it correctly, because if you name it the wrong thing, it's not like CPC or Copeland where you could still see what it is. It's going to be named whatever it's going to be named. Now, if you do screw up and mess up naming, if you delete out the name and just hit OK, it'll go back to what it was originally named from the beginning.
So if I were to change this to blah, 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 blah,
Yep.
and I go like that, and then
now
it's
click
there.
on it, delete it.
Delete. Okay.
Yep.
Oh, yeah, it does do that. It's almost like the undo button on the E2.
Yeah, so it's there. So it'll go back to it. Now, if you click on the address, so the little gear, now it's going to give you a couple options. You have calculated, which would be from a calculation. You have AKCM, which is going to be 99% of the time where you're going to use. That's going to be your actual inputs from your boards. I've never used the controller one or the AK access. I have no idea what they do.
Controller would probably just be a case controller.
Maybe, yeah. I would assume so, probably. And
Right.
then for some reason, like we have 0 case controller stores out here. So AKCM is going to be your main thing. So you got the first one is going to be your node, whatever the original first part of the board train is. Whatever that is, what holds your address for the actual board train. So if it's on there, you're going to have 3 dials. You're going to have the first one is generally set to 0. That's going to be in the hundreds. It's going to be pretty rare that you have node 100. Okay. The second dial is in tens. Number 1 is 10. Number 2 is 20. Number 3 is 30. So it goes in tens. Okay. The next one is single digits. So 1 through 9. Okay. So if it's 0 on the first dial, 0 on the second dial, and 1 on the first dial, that is board 1. Likewise, if it's 0 on the first dial, 1 on the first dial, and 1 on the second dial, that's board 11. So it goes 1 through 9 on each dial. So that is your multiplier of your boards, how you address them.
And that's just for your node.
Correct. That is for the first node in the train. Okay. Now each additional board after that is its own address. So if your addresses are 001, that's going to be node 1. Okay. And then your first board is board 1. Your second board is board 2. Your third board is board 3. So it'll go 1, 3, and then the next is going to be your point. So if it's relay point 1, it's going to be 1, 1, 1. If this was board 2, it would be 1, 2, 1. So it just goes on. Now, same thing with your analogs. Your analogs are going to go, it's going to be analog board 1. If it's a combo, it's going to be 1, 1, 1 point.
Yeah, and you can have one module, like it'll separate it. So imagine if you had a multiflex board, right? The multiflex board typically has 16 AIs and 8 ROs. Essentially, it's telling that module or that board, if it was a multiflex board, to be board 1. And then it doesn't mean you're doing that as well for it. It knows the difference between it having it for a relay and having it for an analog input.
Correct, because you could still have a board 1, a analog input, and a board 1 analog output.
Yes.
So just be aware of that. Now, there is a service button on here. I've never used it, and I think you have to be set to address 0 to service pin it. Really? I've only used the service pin button on the 255. I've never used it on the 880A, so I don't know if it's still a thing. No, that was on the old LAN modules. So the old TP78s. I don't think the new ones have it. The RS45s, I haven't paid attention to it, to be honest with you, because I've never used it, because we always use the address dials because they're super simple. Just make sure that you shut the power off to them when you address them, and then turn the power back on, because sometimes it'll hold the old address.
Also, make sure it goes. If you don't hear it go clicky, sometimes it won't work. I'm going to pull something up real quick, brother. Hold on.
Yeah, and then sometimes it's hard to see where they are. Oh, that's a terrible picture. Why is the first picture so clear? Like the one that we need to see is so shitty, but like the ones next to it are so clear.
Okay, I'm pulling this up because I didn't know you were going to get all into the addressing. So since you did, I pulled this up with the quickness. Anyway, this would be, son of a bitch. This is where the node address would be. This, if we could actually see, this would be the rotary dials where it'd be 0, 0 to 9, right? So if we have node 1, it would be 0, 0, 1. And then this would be module 1. And then this would be module 2. So even though you can have analog inputs here and relay outputs down here, either way, when you're addressing it through the controller. So right now we're doing relays. So we could have address 1, module 1.
That's module 10.
I fixed it. Point 1. Thank you. All right. That's we just did that for the bleed valve. Okay. So now I can actually go to my sensors.
It's going to put these in order by the module numbers. So you may not have your wording in order. It's going to go in order by module numbers.
So I can do 1, 1, and 1.
Yeah.
And bango. So I can still have a module 1 with the same address for a sensor and a relay, and that's because it knows that, okay, these up here are analog inputs and down here are relays.
Now, I hate doing it this way. So this is where I use the web UI version, because it pulls up a page when you're doing all your addresses. When you go to do it, it pulls up an entire page, and you could just type them all in at once, and then type all your descriptions all in at once instead of going into each individual one on the gear like you are.
Okay.
So it pulls up a page of them, so you can go down the row and just go boom, 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 1-1, 1-2, 1-3.
So how do you do that? Since we're talking about that, because like I have this network directly right over here.
Go to Google.
I gotta make sure I don't have anything bad on here first. Hold on. I don't know what I was looking up last. Go ahead.
Type the IP address in.
192.168. Why are you laughing?
If something pops up.
See, this is the problem I was having. That's why I had to actually end up using this right here.
Do you have HTTPS enabled or disabled on the controller?
We can look at that real quickly.
So go to configuration. Go to comms. Go.
Oh, it's 155.
Yeah.
Hold on. Oh, look at that. There we go.
He doesn't remember the user and password he put
Stop it. Oh, okay. I have tags on every single controller in here, so I can remember it. Yay.
Okay, now go to configuration. Go to network nodes. Go to points. Top. No.
I was shutting off the noise.
Oh yeah, I hate that. Go to points.
Okay. Points. I was moving that because I didn't know which one was what.
Click on. Go to relays. You're on relays. So click on the gear.
This one.
No, the bottom gear. No, on one of the relays. On one of the relays. Click on the gear.
Oh, hold on. I gotta go back.
Oh, it didn't do it.
No, no. Hold on. Network nodes.
Oh, you may have to be inside the actual configure. Go to configuration. We're in the wrong. Go to control.
Oh, no. Control.
Okay, go to refrigeration. Go to addresses. Okay, go to relays. Okay, now click on the address gear. No, the gear by the address. There it goes.
There we go. Oh, that's nice.
This is way easier. So,
yeah, shit.
So it takes half the amount of time.
So
this is where I'm saying this gets confusing because certain features only work on certain things.
That's nice. So then you can actually roll through this and just name them whatever. And then Oh, and so this is everything that we actually programmed thus far, right? So we programmed our compressor group. We put in a subcooler there. We put out our split for our condenser fans that are grouped together with our hot water heat reclaim, inverter stuff. And so this is just the relays for all this stuff at this point. Yeah, so you can just roll through this and 1, not 20. Oh, this is so much freaking easier. And so this is where you're talking about just renaming it here.
Yeah, so it's way easier to do it this way.
Okay. All right, I'm not going to sit through and address every
No,
single
don't. Yeah, don't. But this is the same thing with your inputs. Same way.
Okay, so then we go to sensors, and then we hit the gear by address, and it should bring up that whole kit and caboodle.
Correct. So this is the easy way to do this.
Damn
Then
it.
then you could change your sensor types to whatever you need it to be.
Yeah, you can. I like that. That's nice.
But this only works on the web UI.
I see that now.
Yeah, so it only works on the web UI. And then if you make any like custom sensors, that'll be in there too, which we'll go over that in a few minutes, how to make a custom sensor.
Yeah, we can do that. So let's just say you have a liquid level, and this one's showing, like, I'm assuming 0 to 5 is really what this one is, right?
Correct.
And like this one's 0 to 10, 0 to, or 1 to 2 for the liquid level. Which can be dumb because you'll have other ones that are like not that. If you had to do that, normally this would say, if we had any calculations up here, we could do that there. You want to do that next? Like, let's just say we do the liquid level. Okay, because the only one that I don't see up here, if we're doing a liquid level, they don't have the 1 to 6, and that's what the Hansen rod typically is, right? So if we go to configuration and we go to control and we go to miscellaneous, right? Yeah. Because we have to make a miscellaneous sensor. Oh, we have to we have to tell it that we want to add one. So we have to go to configuration, control. No, that's control. So
you want to make if you want to make a miscellaneous sensor, go to miscellaneous. Okay, and then we're going to go to conversion factor.
There you go. So number of conversion factors.
1.
Yes, sir. Okay.
Okay, now this is what it's going to be. So you're going to select your units, which is going to be percent. So we're doing receiver level.
All right, so we'll do receiver
1 to 4.5 to 4.5.
How come it's not letting me change the name?
I don't know. So sometimes the web UI gets wonky. What?
Nothing.
Some things work on the web UI, and some things only work on store view.
There you go. Now it works. Receiver 1 to 6. That's what I'll call it.
Yeah.
Units, we're going to do percentage. So this is where you do your min. So this is where you do to 1 volt. And this is where you do to 60 volt. And then 0 to 100%.
Yep.
Done, son.
And then now when you go to choose it for the input, it'll be named that. It'll be named REC 1-6.
So then we go back to refrigeration. Then we back to control.
Today's episode is sponsored by the RefRushield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
Where's the system?
Right there. Let's go to control. Go to refrigeration. No, go to refrigeration. Go to stop it. Stop it. Addresses. The top. Right. Relay.
Sensors. We're going to sensors.
Yep. Just stop it. Click the gear on one of them.
Liquid level right here.
It doesn't matter. Just click the gear on one.
Yeah, but I want to put it where it belongs.
Yeah, but if you click the gear on a random level, it brings up all of them. See?
All right. All right. Liquid level. So type.
It's going to be all the way down the bottom, usually.
Receiver 1 to 6. Look at that. Now we got a custom.
All your custom ones will end up down at the bottom.
So now it says instead of having the address that it typically would have, the type it would, then it's that custom, and then we still have to put an address of where it actually belongs.
Correct.
Done. Okay.
Same thing if you're doing CTs for compressors and you don't have a 100 amp CT. You'd make it like it says the 30. You'd make it 0 to 30 amps, and then it would be 0 to 5 volts, and that's how it's going to scale it.
So let's talk about this real quick because this confuses a lot of people as far as it says. Yeah, you know what I'm going to say. So when it says type, it says voltage, no voltage, open, close, and latching. So if you're using this for just a digital in, think about it. What happens if you have an open switch on anything? You typically get the source voltage, right? So if you were to do no voltage, that would be active on a closure. Yes.
Yeah, it would show. And fuck whoever made these high volt boards for Comtrol and Danfoss.
So the thing that I'm confused about though is I used to know the answer to this. I actually had something taped. Why it just says open and closed here, and why it says voltage and no voltage. Because any kind of input is going to be, it's either going to have voltage or not, because you have voltage coming from the board itself.
No voltage are the high volt boards, so there's no voltage coming out of those.
Oh, okay. I thought
those are for the
205s.
Yeah, fuck those boards.
205X8 something niner. Don't change those out on Comtrol. You got to watch those because Comtrol and Danfoss both have high volt input boards. And if you put normal input boards in there, they're going to go smoky, except it's big pop. You are right, though. It's 205s. So that's for those. So if you have 205s and you're actually looking at if it has 208 volts at it, that would be voltage. If it's 208, if it's 120 and has 120 volts at it, that's going to be 120 when it has voltage. No voltage would be it's an open switch, meaning like it doesn't have 208 there. And then open and closed would be your actual relays, the actual inputs. If it's a DI, if it's open or closed, that's going to have board voltage going through it. Yes, sir. And let's see what else we got here. All right, so on-off variable outputs.
Yep.
So this is where you would have, this one is for my inverter for BA1. So our first compressor, I believe that we made an inverter. So bam, right here. So if you were doing a core sense, you'd have to have a special one, correct? We'd have to do a conversion factor for that. Would that be correct?
I don't know. No, so it's only 0 to 5 max steps or 0 to 10.
But I think we could, I don't know. I wonder if we could make a conversion because we'd have to.
For what?
If you were doing a digital scroll, right?
No, that's not how it works. So with the digital scrolls, you have to set the minimum percentage. So if you'd set it to 0 to 5 volts, and then you would set it to 30% minimum in the suction group. And you got to figure it out that way with the linear interpolator.
Gotcha.
to figure it out. It's I don't know why.
Gotcha.
But
so max steps, that's not. Nope.
yeah, you're going to change it to 0 to 5. And this is how you set your AO up.
Overdrive and internal history is max holding current. These are for the EPRs for this one, for that stuff down there. So we'd have to, we'd have to look into that and see how that would roll. So max steps. Oh yeah, those are for the EPRs that we did for those. And this would be our inverter. So we'd have to go. I wonder if you'd have to go. See, I thought you had to do another conversion factor where it would be voltage to percent then. I could be wrong.
I've never done it that way. That's how I've always set them up that way, and it's how I've always seen them set up for the digitals.
Okay. Fair enough.
It's not the greatest, but it works. As long as you figure out like a digital, if it needs to be 1.5 volts for it to run, you got to figure out with the linear interpolator out of a 1 to 5 volt 0 to 5 volt signal, what is that 1.5 volts going to look like? So it ends up being like 30-35% minimum.
Understood. All right, so that's it then. We've set up a variable output. We've set out the inputs, outputs. We have the proof. You can have your door switches, yada, yada, yada. So that's really basically done. Do you want to do some basic calcs, or you want to call it?
No, we can go over a couple basic. God damn it, a couple basic calcs real quick. I'm not the best with the calcs. They really drive me into a rage.
Okay, so let's do configuration, control, miscellaneous, calculations. So it looks like these ones are doing different things for. Okay, so we can do a new calc. What? Hold on. Why is it want to go to 9? Did it have a 9 and then someone deleted the 9? Yeah, that's why. So it had a 9 and then someone wanted to delete 9. So we could just do, okay, and then we go down to calc number 9 that it just made. And so you can do generic clone. So that's the one thing with Danfoss that I don't like, is that you can't just have a multiple address on something. So you'd essentially have to clone an input. So if you had
insane.
So you'd have to. So if you had a temperature sensor that, I don't know, let's look for something that we did before. So IO. So you have to tell it what kind of sensor you're cloning. For all intents and purposes, let's say we're going to do the sensor that we already addressed, right? The percentage, the receiver level, because we want to do some other kind of alarm for something, right? We want to use that same value. Maybe you want to, I don't know, not have the alarm go on when it's in pump down. I don't know, just something. So what you would do is then you did a generic, you did SSI clone. All right, so we're cloning that one, SI, and then this is what you're going to use for, we already did that. Input, this is the one that you're going to steal. So I thought we did that. Oh, liquid level right there. B liquid level. Yep. That one right there. And then now it's basically cloned. So now if I were to make another cut in and cut out for something, I can then go back to miscellaneous, back to calculations. I then can make another calculation. Right now it wants me to make it number 18. Fine. So I'm going to go down to that right there. And then I'm going to use the sensor that I just made as far as the clone. So it's going to be SI percentage. And let's see, we're going to do I thought there was a cut in and cut out thing here. It's just going to be generic then. And then this is now what sensor I'm going to use. Oh, sorry. So now when I go to what sensor I'm going to use, there's our clone of our receiver level now. Bam. So now I can use this for whatever. So I could do, if this sensor is greater than or less than 5% for whatever time, then I can actually make this thing alarm. And then I can actually make this calculation like a separate alarming thing. Anything you want to add on there?
No, the only nice part is like with the 880 is you could have multiple calculations in one calc block now. So like you could add another calculation down below. So before it was you had to do it was one function per calculation block. So if it was an and or an or, now you could add another calculation block down below. So you could have the first one where it's true or false, and then you could add a second one and a third one.
And add more lines to the calculation itself.
Yeah.
Okay.
So that's the calc blocks are cumbersome. I'm going to be honest. That's one of my things I hate the most about Danfoss is the calc blocks. I wish they would just either go to Boolean line logic like Copeland, or they would just bite the bullet and then go block logic. Like it's so cumbersome and hard to troubleshoot.
But it's more like anything else though, man. Like the more you use it, the more.
Even at that, I've done a bunch of them, but even at that, it's just so cumbersome to troubleshoot and look through, and it's just so much more room for error. And you go to, yep. So it's going to be, yeah. What's really annoying? Yeah, it was really annoying if you mess up like the IO and go to change it back. It wipes everything.
So IO is going to be anything, the open or close, right? So if you want to do that, and then watch what happens. So if I do, let's just say I wanted to do something off of PSI, right? And I switch to PSI, then it goes automatically right back to generic. So if you started putting stuff down here and didn't get this set right off the bat, then you've now wiped out everything. Oh man, I'm going to screw this up now. Watch me. Dave's watching this and he's like, what are you guys doing? Calculations. 19. So SI1. So if SI1 is greater than, that's what I want to do. If SI1 is greater than whatever I have for SI2, then it would basically make that true and then yell at that thing and tell it to turn condition. Value, data point, yeah. Damn it, why was this easier with the 255?
It was way easier with the 255.
I feel like an ass now. Because you would do some kind of relay, right? On here, whatever relay that you're going to do to shut something down. Let's see if maybe I need to just throw something in there. Oh, I feel like such an ass now. I'm just going to have to delete this whole section out of here because I am running blank here. Because before you would just you click on each one of those things and then do greater, less than, or whatever on each one. Oh, there we go. If SI1 is greater than, oh, okay. See, I have a failure here. I think it's because I have, it's because when I first set this up, that's why. When I first set it up, it should have been something along the lines where what I was trying to do is the RO. So that's what I would have had to do.
Yep.
Damn it. All right, I failed miserably at that.
We'll have a class just on that after mess around with some more. It takes me a little bit to get a calc right. Complicated.
Yeah, but what I don't understand is it should have just been an easy cut in, cut out, right?
You think that every time, but then it's not.
That's funny because I went through a bunch of stuff with Dave the one day. I was like, yeah, I got this. And then all of a sudden, I was like, no, I don't remember. Damn it. I'm just going to stop right there. Because I told him, he emailed me. He's not that bad, not that bad. He did have something that we said that was wrong. We were talking about on the suction. It was just an alarm. It didn't actually shut down whatever we were talking about. He's like, at minute 32. So he had a little note there. Damn, I don't understand why I can't add a variable out control. Miscellaneous. Variables. Why won't it let me add a variable out? Kevin.
Oh, sorry. You gotta have a calculation with a VO already set up, and you have to make a miscellaneous variable out.
Oh,
So you have to tell. No, you have to go back to go back to configuration. Go to control. Okay, go down, all the way down. Scroll down.
Oh, there we go. There we go.
Yep.
I always forget about this too. Okay, so now I can go back to control, configuration control, miscellaneous variable outputs. There we go. So this is what I was thinking what we could do with that, Kev. This is what I was talking about where we could do the, you can't even do it there.
You can't.
Oh, right here. There we go. Output at 0. So this is where you can do 1.44. What?
Nope.
What do you mean no? 1.5? Okay, 1. Did it take 1.5?
It did not.
It did not take 1.5. Why didn't it take 1.5? That's freaking silliness.
Oh, the disappointment.
What the?
Hey, man, whole numbers only.
That's ridiculous.
The Dutch whole numbers.
Damn it, before you insult anyone else. Hey, we're going to go. I'm going to figure out if I'm going to have to delete that whole last section.
Oh, yeah, you are. Because you're going to get self-conscious.
Oh, yeah, 100%. All right, guys, we'll talk to you guys later. Bye.